Hello students, today we're going to learn section 5.5, the law of sines. With the law of sines, the law of sines will allow us to solve a triangle. Remember, solving a triangle means find the measure angles or angle measures of A, B, and C, and find the lengths of side A, side B, and side C. Here are the law of sines. It's the ratio of sine A over A equals the ratio of sine B over B equals the ratio of sine C over C. You can also use the formula as A over sine A, B over sine B, and C over sine C. So again, you can also use the formula, the law of sines, with the reciprocals. All right, so solve triangle ABC given angle A is 36, angle B is 48, and side A is 8. So the process is we're going to use the formula, the law of sines, and here it is. So we have sine A over A, sine 36 over 8. Again, sine A over A equals sine B over B. We're going to find this missing side. You could just use your cross product property. So cross product property is we multiply across. So this is B sine 36 equals 8 times sine 48. Divide both sides by sine 36. So now B is by itself. So B is equal to 10.115. So let's write that down. 10.115. All right. To find angle C, we know that all the angles in a triangle add up to 180. So here is A plus B plus angle C equals 180. Combine like terms, isolate angle C. So angle C is 96 degrees. To find the missing side, we'll just use law of sines again. So I'm using sine 36 over 8, sine A over A, sine A over A equals sine 96 over C. The reason why I'm using 96 is 96 degrees is the angle measure of angle C. So again, use a cross product property, and now we have sine C sine 36 equals 8 sine 96. Divide both sides by sine 36. And C is approximately 13.536. So 13.536. Now we have to make sure the answers make sense. So in geometry, you learn that the smallest angle will have the smallest opposite side. Well, this is the smallest angle, this is the shortest side. This is the largest angle, this is the longest side. So the angles and the sides correspond with each other. Okay. Next, we will have example 2. Example 2, solve triangle ABC. This time, instead of two angles and a side given, we have two sides and an angle given. All right, so let's start off with sine 26.3 over 7. So remember, sine A over A equals sine B over B. Well, sine B we don't know, but we know side B is 6. So we don't know angle B, but we know side B. And again, this is just a law of sines that we went over at the beginning of the lesson. Again, use the cross product property. And now we have 6 sine 26.3 equals 7 sine b. Divide by 7 on both sides. And now we have sine b is equal to 0.379775. To get b by itself, if you remember from the last section, you take the inverse sine. So when you take the inverse sine, this and this will undo each other, and now we're left with angle B. So angle B is 22.3 degrees. So far the answers make sense because 7 is longer than 6 and 26.3 is greater than 22.3. Okay, now to find our side C. To find angle C, again, it's just the sum of all the angles is equal to 180. A plus B plus angle C equals 180. Combine like terms. Subtract 48.6 from both sides. Angle C is now 131.4 degrees. So 1 equals 131.4 degrees. Okay. Now to get side C, we'll use law of sines again. Now what I prefer to do is always use the side and the angle that's given. I know we could have used B and angle B, but I prefer what's given. So you'll make less mistakes. Since I want side C, I'm going to put the sides in the numerators and the angles in the denominators. So this is C over sine C equals side B over sine B. I'm sorry, side A over sine A. So now we multiply both sides by sine 131.4 degrees. Or you could have used the cross product property. It's all the same, it works the same way. So C is equal to 7 sine 131.4 over sine 26.3. C is roughly 11.9. Now let's check if the answers make sense. Okay. So the largest angle is 131.4 degrees, and this is the longest side. So these correspond to each other. This is the smallest angle. This is the smallest angle, 22.3. That's the shortest side, so this angle is between these two angles. This side is between these two sides. So the triangle angle inequality theorem holds true. Okay, next, solve triangle ABC again. This time angle B is given, side B and side C is given. All right, so now let's set this up. So again, since I'm looking for the angle, because I want to use this information. I don't want to use this information because I'll have two unknowns. If I use this information here, I'll have only one unknown, which is angle C. So sine C over side C, sine B over side B. Now I'm going to multiply both sides by 62. So instead of using cross product property, if we always put the unknown in the numerator, we don't have to use the cross product property. All right, so sine C equals 62 sine 88 over 14. Well, when you multiply all that and divide, you get sine C is 4.425. Now, if you remember from chapter 4, the range of sine can only be between 1 and -1. But this 4.425 is outside the range of what sine can be. Therefore, if you put this in the calculator, if you take inverse sine on both sides, it's going to say error. because this is beyond 1. It's beyond the range of -1 to 1. Therefore, triangle ABC has no solution, and you could also say triangle ABC does not exist. Okay, so that's pretty funny. This is coincidental. Triangle ABC does not exist. It's the same as that. Okay. All right, that's example 3. Last example. The last example is the ambiguous case, meaning you're going to have two possible triangles. So let's start off with what they gave us. They gave us an angle and two sides. So again, since I want angle B, I'm going to put the angles in the numerators, the sides in the denominators. So sine B over side B equals sine A over side A, just like the law of sines. So multiply by 7 on both sides. That reduces. So now we have sine B equals 7 sine 30 degrees over 6. So B is roughly 35.7, because when you take the inverse sine on both sides, you'll get B is equal to 35.7. So now we know angle C plus angle A plus angle B is equal to 180. Again, combine like terms, isolate C. We have C is equal to 114.3 degrees. Last thing we have to do is, let me put this here, is find side C. Okay, so now to find side C, we just use the law of sines again. C over sine 114.3, and I'm going to use the original information that's given, 6 over sine 30. Okay, so now we multiply both sides by sine 114.3, sine 114.3. That will reduce. So now C is roughly 10.9. Okay. C is roughly 10.9, and it's not degrees. All right, and let's check. Do the answers make sense? Here is the smallest angle, shortest side, largest angle, longest side. The answers make sense. Now this is the ambiguous case, because what we're going to notice is this was B. Let's find, we'll call it B prime. Okay, I want to just change the notation of angle B, so we're going to call it B prime. We're going to take B prime, set it equal to 180 minus B. So it's possible for B prime to be 144.3 degrees. So here's where you can tell if you have two triangles. What you're going to do is, this is important here, this step right here. So since angle A plus angle B prime is less than 180, we know angle C prime exists. So this is very important. Now, if the sum of these two angles were greater than 180, then you will conclude that only one triangle can exist, and it's this. So if these two angles were greater than 180, then only one triangle exists. But since the sum of these two angles is less than 180, that means angle C will exist, therefore we will have a second triangle. And that's what I did here. I took angle B plus angle B prime plus angle C prime equals 180. Combine like terms, angle C prime is equal to 5.7. Now, that means that angle C prime is 5.7 degrees, angle B prime is 144.3. Again, this is very important here. If the original angle plus angle B prime is less than 180, that means there's enough degree measure to have angle C exist in a triangle, because the sum of all the angles in a triangle is equal to 180. So let's write this information down. Angle A is 30, angle B prime is 144.3 degrees. Angle C prime is 5.7 degrees. Okay, so now all we have to do is look for side C. Well, using this information, I'm going to put C over sine C equals A over sine A. So that's what I did here. Multiply both sides by sine 5.7 degrees, sine 5.7 degrees. Side C is equal to 6 sine 5.7 over sine 30. So C is roughly 1.2. And again, check if the answers make sense. Smallest angle, shortest side. This is the largest angle. This is the longest side. Now you could find the ambiguous case in your section 5.5, and it will give you a graph of how when you have this information, B prime can be the obtuse angle, and in here B is the acute angle. So it's in your section, and they have a graph and an illustration to show you what I did here. All right, that's it for today. Have a good day.